In this video, I'm looking at a function, what makes something a function. And the lesson is relations and functions graphs. So there's two things I'll mention with this. I think two things. First of all, questions that look like this, where they're giving you a bunch of graphs, and you have to decide which is which. And we'll go with this one maybe here to start with. So if I'm looking at this set, this is called a set of values or a set of points, set A. And set A has 1, 2, 3, 4 points in it. The first point is the point 1, 2. So x is 1, y is 2. And on our general Cartesian plane here that you're used to seeing, the x values are on the horizontal axis here. The y values are on the vertical axis here. So if x is 1 when y is 2, that means when I put 1 in for the domain, remember domain are the input values, that's the x values. So 1 is the x value, and 2 is the range, it's the output, it's the y values. So I put 1 into my function, I get the number 2 that pops out. So 1 goes in, 2, nope, there should be a dot here at 2. There isn't. Nope, there isn't one there either. There's one. Okay, so 1 goes in, 2 comes out. 1 goes in, 2 comes out. The next point should be 2, 3. 2 goes in, 3 comes out. 2 is the range, 2 is the domain, 2 is the x value, 3 is the range, 3 is the y value. So if I put 2 in for x, I should get 3 out for y. No, that's not what's happening here. In this picture, I get 2 in and 1 comes out. That's not what our set A here tells us. This one, I think, works. 2, 3. And you could keep going. The next one should be 3, 4, and 4, 5. 3, 4, 4, 1, 2, 3, 4, 5. Yep, that is the graph that's represented by this set of values. And that's how you look at all of these questions here. At this point, we're not deciding what's a function or what's a relation, and I'll get back to that right now. So select the values that are not functions. All right, so a function, what makes something a function? A function is, I'm going to say this is going to be a terrible explanation. It's something that works. And I'm going to give you an example that has nothing to do with math. So a function would be like a remote control. A good remote control, if you push the volume up button on the remote control, on your TV, the volume should go up. And that's it. That's the only thing that should happen. You push the volume up, the volume goes up. If your remote control, where when you push the volume up button, you don't know if the volume is going to turn up or if your car alarm is going to go off, that's a terrible remote control. You're going to be afraid to push the volume up button because you don't know what's going to happen. It's either going to turn the volume up or your car alarm is going to go off and your neighbors are going to be upset with you because it's midnight and you're making all this noise. That's a bad remote control, and that's not a function. A function, one input, pushing one button, should only have one output. One thing should happen. One input goes to exactly one output. And that's the definition. Definition of a function is for every domain value, there is exactly one range value. Looking at these sets of values, because none of these are remote controls. Looking at the first one here, I put 1 in and 2 comes out. I put 2 in, 3 comes out. So far, different inputs, 1 and 2 are different buttons, and they had different results. 3 goes in, 4 goes out, 4 goes in, 5 goes out. That's okay, that works. I push a different button every time and something happens. That's great, that's awesome. Let's look at this one here, number C, or letter C. -1 goes in, 3 comes out. 0 goes in, 3 comes out. Even though we get the same result, that's okay. I pushed different buttons. And even though I got the same result, that's okay. It's kind of like if you had, I'm going to go back to PlayStation or Xbox or any gaming system. That's like having more than one button to make the person jump on the screen. That's fine. That's not an issue. The issue is in D. So set D here. I push 1, 1 comes out. I push the same button and 2 comes out. I push the same button and 3 comes out. I'm pushing the exact same button and getting 4 different possible answers. That's an issue. That is not a function. So D is not a function. A, B, and C, they're all functions. They're all okay. I'll let you decide what E is, but D is not a function. And the easiest way, the shortcut way of finding the answer to this is if there's any repeated X values, if there's any repeated domain values, and we have different range values for those, that's a problem. So I've got a repeat here, 1, 1, 1, that's a problem. More than one X value, that's the exact same, that's an issue. So you're looking for repeats in the X, and that's what makes something not a function. We've talked about domain and range a little bit. If the domain is 0 to 4, you plug 0 in for X, because the domain are the X values, and see what Y has to be. You plug 2 in for X, and see what Y has to be to make it work. 2 minus something equals 5. You plug 4 in for X. 4 minus something equals 5. And that's how you get those values there. Okay, going back here quick. This picture right here is not a function. This is not a function because I put 1 in and get multiple results. This is a function because I have 4 different inputs and I get different outputs from there. There's something called the vertical line test for a graph. And it says if you can draw a vertical straight up and down line and only touch the graph once, then you're good to go. Vertical up and down line, touch the graph once, good to go. Vertical up and down line, touch the graph once, good to go. Vertical up and down line once, twice. I touched the graph 2 times on this vertical line. That is not a function. So that's called the vertical line test, and that's how you can tell if it's a function just looking at a graph. So we've talked about functions from a graph, we've talked about functions from I lost it. From a set of values. There we go. And that's how you can determine if something is a function or not. Hopefully those 2